Okay, second method. Let's talk about the horizontal form. Okay, so when we add or subtract polynomials, we can use what's called the horizontal form. And in this form, we simply want to use the associate and commutative properties just to regroup and combine our like terms. So we have problem 5a to the third. I think we just did this earlier, but I want you to see what it looks like doing so, and that way you can have a good comparison. 5a to the third plus 3a squared minus 6a plus 12a squared. Okay, so, and that's going to be plus 7a to the third minus 10a. So let's look at adding these two polynomials. The first thing we want to do is identify our like terms. Okay, so same thing. Our like terms are a to the third, a to the third, a square, and a. So to begin our process, let's use associate property and regroup here with 5a to the third plus 7a to the third. Okay, so we'll go ahead and group those up. Now, here's something that I always say. I like to make sure that I'm completely, that I've used them and I'm not going to use them twice. So I'll just put a little line through them. Okay, so the next thing I want to look at is grouping my a squared. So let's go plus, put another grouping symbol, and I have 3a squared, and that's a plus 12a plus 12a squared. Okay, so I'll use these, make sure that I know that. Now, only thing I'm left with is my, so let's go ahead and put a plus sign in. You'll see what's going on with this. And I have a negative 6a minus 10a. Okay, so now all of my like terms are grouped. All I need to do now is just go ahead and add them up. So here I have the coefficient 5 and 7. 5 plus 7 is 12. Bring down my a to the third. So again, here I'm looking in here, and this is a positive 3, so I can go ahead and put my plus sign here, and then I have 3 plus 12. That's going to give me 15a square. Okay, now these are they're combined, but I have plus a negative 6a minus 10a. When I look at these, I'm going to keep my sign, and I'm going to add 6 and 10, which is going to give me 16. So I don't need to put a plus. I can just go ahead and put minus 16a. Okay, so again, I literally found what my like terms was. I used commutative and associative property and regrouped. Okay, and once I regroup, I just simply combine my like terms. Okay, so that's pretty much how we do that. Let's take a look at one more and see how well it works. So we'll just call this problem number 2, and let's just use something really simple here because they're not that difficult. So we have 2x squared plus 6, and let's add to that plus, let's use 4x squared minus 3x plus 2. Okay, so let's regroup and look for our like terms. I see x squared and x squared, and I see the constant 6 and 2. So my 3x, so it's going to be there, but it's not there for us to regroup. So let's go right ahead and start with our 2x squared plus, that's a positive 4x squared, and we'll group. And what I'm going to do is I'm going to put plus, and I'm just going to put a negative 3x here, okay, and plus, and what I have in my last group is my constants, which are like terms, 6 plus 2. Okay, so maybe we need to stop here for just a second and explain more in depth about these like terms. We say in order for these monomials to be like terms, they must have, the variable must have the same degree. So first of all, they must be the same variable with the same exponents, and then again we say all constants are like terms. So like terms are variables with the same exponents, and like terms are also constant. Okay, so now we should be pretty clear on that. So let's go back and finish the problem up. 2 plus 4 will give me 6x squared. Okay, now that's a minus, so we really can just go ahead and label this minus 3x, and 6 plus 2 is 8. So again, using the horizontal form, we can identify, use associative community property, and regroup, and then add our like term. So those are the three basic ways, or actually two basic ways that we can look at adding these particular polynomials. So we will come back in a short period of time and take a look at subtracting polynomials as well. Thank you, and you have a great one.